Being able to look at a graph and identify the key features is very, very important, especially as we're leaving Algebra 1. So here I have a graph from Desmos, and we're just going to go through the key features that are important here. All right, now the first idea here is the idea of zeros. All right, sometimes we're a little confusing in that we call zeros by different names. Sometimes we call them roots. Sometimes we call them solutions. Sometimes we call them x-intercepts. Okay, we pick out all kinds of random names to call a zero. Okay, what we're doing is we're looking for where this parabola crosses the x-axis. So I picked a very friendly parabola. I found one that had zeros at 3 and -3. So some people will write it as 3, comma, -3. Some people will say x equals 3 and x equals -3. Some people will write them as two separate ordered pairs, like 3, 0 and -3, 0. If you list it off like this, don't put parentheses around it though, because that would make this an ordered pair, and 3, -3 isn't even on this graph. The y-intercept, however, is where the graph crosses the y-axis. So this is your y-intercept. Okay, these were zeros. I'm going to put that on here. All right, so the y-intercept is always an ordered pair. It's usually 0, comma, a number. Here, it looks like that intercept is at about 4.5. Oy, my pen is being picky again. So 0, comma, 4.5. Sometimes, depending on your textbook or whoever published the question, sometimes people will call the y-intercept a number, like y equals 4.5. I personally think that's deplorable because y equals 4.5 is a horizontal line. That's not an intercept. An intercept is a point, so it needs to be described as a point. All right. The axis of symmetry is the invisible dotted line that cuts the graph in half. All right. Cross symmetry, of course. Sometimes people call it as an AOS. You always write it as x equals and then some kind of number. In this case, it's on the y-axis, and so that's where x is equal to 0. But if you don't put the x equals on there, you're not describing a line, therefore you're not describing an axis of symmetry. All right, in this case, the vertex is going to be the same thing as our y-intercept. I should have picked a better graph. But the way that you find the vertex is you look for the highest point or the lowest point on the graph. All right, so because this graph opens downwards, it has a highest point, but these legs here that you see, they continue going down for forever. So there's no lowest point ever on this graph. There's only a highest point. That highest point occurs at the vertex. Sometimes the vertex in the y-intercept align. Sometimes the vertex aligns on a 0. Sometimes the vertex doesn't land on an axis. Usually doesn't land on an axis. Okay? Now, the direction that your graph opens tells you whether that vertex is a minimum or a maximum. So, like I was saying, these legs go down for forever, so there can't be a minimum to this graph because it never stops going down. However, if I were to draw a little stick figure chilling out on this vertex, he is chilling out at the top of the graph. He is the maximum value, or he is at the highest value. A lot of times kids get mixed up between a minimum or maximum depending on the direction that the graph opens. Don't let yourself fall for that.